Hey y'all. Um, uh-oh. I do not have my document camera. Wait, no. Document camera. So you can't see the paper. Okay, let me. USB. Document camera. Here it is. Okay. So today's lesson is proportional versus proportional relationships and non-proportional relationships. We've talked a little bit about this, and so I wanted to kind of give you a guide on how to compare if a relationship is proportional or not proportional, and there's different kind of categories we're going to go through. So the first one is the graph, which is probably the easiest to tell because it's very visual, and you can tell simply by looking at a graph if a relationship is proportional or non-proportional. So for a proportional graph, it has to be a straight line through the origin, and the origin is 0, 0. So a straight line through the origin, and it could look like that. It could be a proportional graph. That could be a proportional graph. Maybe it just starts in the middle and it goes up. But it has to be a straight line. It has to go through the origin. If it's a non-proportional, it might not. It's not necessarily a straight line. It still could be a straight line and not be proportional, and I'll show you. And straight line, not a straight line through the origin. So it has to go through the origin to be proportional. So you could still have a straight line. So that is an example of not proportional because it doesn't go through the origin. Another example of non-proportional might be something like this. This goes through... Shh. In your room, please. Thank you. This goes through the origin. You can see it crosses through the origin, but it's not a straight line, so that is not proportional. So here's an example of graphs, proportional and non-proportional relationships. Now the next section compares the tables of proportional and non-proportional. So if you have a table, no graph, if you have a table, I mean, I guess you could graph it, but that would take a long time. So we want to compare the ratio of y to x, the ratio. And if it's proportional, the ratio is always the same. When you compare y to x, the ratio is always the same. So in this example, I'm going to compare y to x. So 21 over 7, 30 over 10, and 51 over 17. Now, right now, I can't necessarily tell if they're the same, so I'm going to reduce. 21 divided by 7 is 3, 3. 51 divided by 17 is 3. So since all the ratios are the same, that means this is a proportional relationship. Down here, my table is still, I have an x and a y. It's written horizontally, but I'm still going to compare my y over x's. Is that a 1? I think that's supposed to be a negative. I'm not sure. My printer, as you can tell, like my lines didn't get printed, and as you can see, so I'm not exactly sure what's going on right there. And then I have negative 6 over 12. And I can reduce all these to negative 1/2. That's just really weird. Maybe, I don't know what that is right there. So all of these are equal, which means it is proportional. Now over here in the non-proportional, this is the non-proportional column, the ratio of y over x is not always the same. It's not always the same. So in these examples, we're going to compare y over x. So 10 over 6, 14 over 8, and 18 over 10. 10 over 6, 14 over 8, 18 over 10, if we were to reduce these, I could divide these by 2, and I would get 5 over 3. I could divide these by 2, and I get 7 over 4, and 9 over 5. And then you can tell that these are not equal ratios Because if we were to try to find a common denominator, let's just say we found a common denominator between 12, 3, and 4. This times 4, this would be 20 over 12, and this would be 21 over 12, which means they're not equal. You could also change them to decimals if you would like, but they are not always equal. Maybe one or two of them might be equal, but they're not all going to be equal. So down here, I'm still going to compare y over x. So negative 6 over negative 1, negative 3 over 1, and 0 over 2. And this would just be 0. This would be negative 3, and this is positive 6. So again, these are not equal ratios, which means it's not proportional. So if you have a table, you're going to check the ratio. If you have a graph, you're just going to look to see is it a straight line through the origin. Now let's go to the back. We're going to look at the equations of proportional and non-proportional. For the equation for proportional, it's going to be in the form of y equals mx, just y equals mx. M is the slope. It could also be y equals kx, kind of like direct variation. Direct variation, because direct variations are proportional. K is the constant of proportionality, or it's the scale factor. If it's written in the form of y equals kx. If it's m, it's the slope. And they're all the same thing. B is 0, so you don't need to write it. You don't write plus 0 up here because it doesn't mean anything if it's plus 0. Since it goes through the origin, there's not going to be a y-intercept. It's always just going to be 0 because it goes through the origin. I'm going to write the word origin right here. Here are some examples. Y equals 4x. So the constant of proportionality is 4. The scale factor is 4. The slope is 4 over 1. Here is y equals negative 75 hundredths x, which means the slope is a negative. And y equals 1/2 x. The slope can also be a fraction. The constant proportionality can be a fraction. Notice there's no plus anything out here, and it's always multiplying by x. For non-proportional, it would be in slope-intercept form, and it would have a plus b. The slope is the per, there's no constant since it's not proportional. And b cannot equals, I'm not 0. B cannot be 0 in this. I'm not sure what blank I was supposed to put there. B cannot be 0. So in our examples, we have equations. If it has a plus b or a minus b, that means it doesn't go through the origin. Not through origin. I can't write slang. Not through the origin. This is not linear. X squared is going to have a curve in it, so that means it's not linear. And this has no x value. It's just y equals 3, which if we were to graph y equals 3, it would be a horizontal line. So again, not through the origin. So those are examples of equations that are not proportional. And then the last one is real world situations. If you have some real world problems, here's how to tell if it is proportional or not proportional. There is not a no matter what fee, no flat fee. If it's proportional, there's not going to be like a no matter what. There's not going to be a flat fee. There's not going to be a joining fee. There's not going to be a shipping fee. There's not going to be any kind of like registration fee. There's no matter what fee. So in this example, a new compact car travels 288 miles on 9 gallons. How many gallons of gas would she need to travel 500 miles? It's just a straightforward 288 miles on 9 gallons of gas. So this doesn't have any kind of fee on it. There's no fee, so it would just be proportional. Alice is starting a babysitting business. She decides to charge her clients $12 per hour to babysit. How much would she charge a family to babysit 3.5 hours? So in this example, we could say our equation is y equals 12x because it's $12 per hour. There's no like any kind of plus an additional $10 for her driving over to your house. It has nothing to do with that. it would just be $12 per hour. Now, if it's non-proportional, there is a no matter what fee. There is a flat fee, kind of like a joining fee or a shipping fee. A bakery will decorate a cake for $7.50 plus 25 cents per word. How much will it cost to have the message, "Congratulations on your retirement, Joan," written on a cake? So here's the important part right here, $7.50 plus. If you want to buy a cake and get it decorated, you have to pay $7.50. Then you have to pay 25 cents per word. That per word, that would be your slope, plus the $7.50 base fee. So if there's like a base fee, a flat fee, that means it's not proportional. Because it wouldn't go through the origin. That $7.50 means you would have to graph up 7.5 on the y-axis, so it would not go through the origin. A cleaning service charges $15 per hour to clean houses with a one-time supply fee of $80. How much would the cleaning company charge if it took 4 hours? Again, you see the $15 per hour, that's your slope, plus a one-time supply fee of $80. This right here is the y-intercept. That means before they even come over to your house, you have to pay $80 for them to buy the supplies. Then you pay $15 per hour. So you have to pay $80 for them to just come over to your house before they even start cleaning, which means that's a flat fee, a supply fee, and that would mean it's non-proportional. So again, these notes are just a little to show you how to tell if something is proportional or not proportional by first glance.